I don't know if people are joining slow or just me light attendance today, but looks like a lighter call than most so far. Might as well go get started though. Welcome to the June OCP Server Project call. We do have a fairly light agenda, so it may not take the entire hour. We did have the EUA Summit a while back, so all those DEX recordings are posted on the website under past events. If you want to look at any of the content that is now all online. Upcoming, we do have the APAC Summit coming up in August. And of course, the main global summit in October. The call for papers for that is already done, and we're starting to be able to review those submissions. As expected, we got a third to half as many or many more submissions that we have slots for. So it looks like we're going to have to reject about a third of the submissions. So know that we are going to have to go through those and carefully look at which ones we can accept and which ones we don't have space for. Also ongoing, there's an open system for AI workshops. We had one on Tuesday, and there's going to be 2 more in July and August. So look at the blogs and the email list for details on those. Michael or Greg, do either of y'all have any other updates from OCP Foundation?
Nothing from me. Look forward to giving you a hand with the submissions and working our way through those, but yeah, nothing additional.
Yeah. Doesn't look like we have Michael on, or anybody else to give an update from Foundation. But I haven't heard of anything else going on other than all the preparation for Summit. Up next, we have Damien for Nick Project. You can do verbal, or you want to share?
I will do a share.
All right, go ahead.
Okay, screen 2. Okay. Yeah, this is the OCP update for Server Project. Couple updates today. First of all, similar to what John had mentioned, we are also working on OCP Global Summit. So I scanned through the track that there's 4 NICs related abstract was received, and then the track has close to about 30 submission. The track NIC currently in is called Server AI Co-Design NIC and HPC track. As John had mentioned, it is also about like 1/3 will be accepted, probably 2/3 likely be rejected from this track as well. And then on behalf of the OCP NIC, I also submitted the OCP Innovation Relay Space request. So I think the request, the submission for Innovation Relay is open until somewhere mid of next month. So it's still open, yeah. So I'll hear back from the community after that. So this is a snapshot of the OCP Global Summit session. Yeah, the next part is like for the community to review the abstract and make the selection of what goes through. Next part on the thermal workstream. This one we have a pretty heavy thermal workstream update. I made a summary. There is actually a backup slide that have more details in this. So basically, thermal workstream we're working on.
Well, as the type classification, for example, booking components is kind of working. So
Pedro, can you go on mute?
Kind of Move has done most of those, which is
okay
going for the review because Aaron just review it. So yeah, everything related to this kind of thing, and also Jira automation.
So Pedro, can you go on mute? I'm not a.
Seems
I
not
don't have the ability to do that.
Yeah, get a matrix, so kind of
Greg, are you logged in with the ability to mute him?
No, I can't do that. That's what I was looking for.
Or not. Taking back this data metrics. But I'm
That's
about
not the correct way of using.
Pedro,
Pedro,
Pedro.
Use a bribe and
I don't know if anybody here has the ability to mute him.
PR. It's working in bookings, so I think that we'll be leaving by 1 week. We'll see how it goes. Maybe by Friday, we can just open up a PR.
Yeah.
Yeah,
This is
data metrics.
frustrating.
If you can't mute him, can you kick him?
No,
No.
we're not logged in as administrators, and since Michael didn't join, I don't know if anybody here is actually an administrator on the call.
Okay, I will try to speak out louder. Is that the case? Will it be better?
Yeah, go ahead and talk louder. I'm going to drop off and see if I can log in as an administrator if he's still going.
Okay.
So go ahead, Damien.
Oh, okay, sure. Yeah. Basically, the thermal workstream has pretty high, a lot of content today. So yeah, basically, we're working into the optics power, which is going higher and higher. Which is this is an area that the workstream need to resolve and poses some more challenges. The next part is we are looking into liquid cooling as one of the options to solve these problems. So Meta have some proposal to the OCP NIC community and the thermal workstream. And then next is we'd like to thermal workstream would like to see feedback with the vendors of the NIC, the liquid cooling roadmaps, and also work on this kind of thermal simulation to check that whether we have sufficient liquid cooling benefit for the TSSF form factors. Okay, yeah, I think Pedro, thank you for muting. Okay, yeah. So the next part is the TSSF thermal test fixture. So the good thing is we actually have the thermal test fixture and OCP NIC able to connect through the HPM or the motherboard through MXIO cable, and it's working. There are some issue found, so the next will be we need a respin for this particular thermal test fixtures. And obviously now the things are working, so the next part is to ensure that this is good for thermal testing. Yeah, and then the next part I would like to highlight a little bit. Maybe some of you have also read it, as I believe Chuck sent some email through public phone, the public reflectors. So there are also some discussion in that mail thread. So basically, we are looking at different form factors that can operate as a NIC today. So PCIe CAM, the APAC form factor, SFF, DSFF, and also SNIA PMM. So one of the things that at least I believe this form factor doesn't have enough density in some of the application. So there's one exploration workstream. They are looking at how to increase the density for a very specific NIC use case. So we are looking into how do we add more PCIe lanes and power and cooling in a smaller dimension. So these are some of the things we are looking at. It's probably a bit early to have a real proposal within OCP NIC workstream and the server groups that we are invited. We are looking into bounding this problem statement and see whether we have a general alignment that is more than one company problem issue to tackle this as an industry standard. So just to let folks know, there is this thing going on. If folks are interested to join us, we meet bi-weekly on Monday. Yeah, every other week. The next one is next Monday. So yeah, here are a couple updates from OCP Nick for last month.
Okay, thank you, Damien. I don't see Brian or Sean on now. We'll see if they join in a few minutes. But we can let Hal Lockett, who's doing a presentation on the 48-volt peak power, go ahead and get started on his presentation. Hal?
Thanks, John. Let's see, is this going through okay for everybody? Can everybody see?
Yep, we can see your share.
Awesome. All right. Thank you. Okay, just to very quickly introduce myself, my name is Hal Lockett, and I'm a system architect at T Connectivity. Also, just want to acknowledge a couple of folks from my team that are also with us today, Michael Minkhouse, Nick Pease, and Rick Carreno. So thanks for coming today. And this is just going to be a quick update on the DCMHS 48-volt interconnects. So for our agenda, first a little bit of background and why we're talking about enabling 48 volts inside servers with DCMHS. A little bit more information on the 48 volt peak power and 48 volt dedicated supply, the requirements from the committee, some cable and connector assembly design details, and then finally a couple highlights from a design specification that will be contributing to OCP very soon. So first, just some quick background. Why are we here talking about 48 volts inside the box, inside servers, and just kind of taking a step back and looking at what we're seeing both from a chip standpoint and a rack power level standpoint is both, the chip power levels are increasing significantly and density is also increasing, and subsequently our server and our rack power levels are also going up along with that. And especially within servers, we're really reaching the limits of what 12 volt architecture can do. Specifically from a power delivery standpoint, just being able to transfer as much power as we need to within boards. And then as well as just the wire gauges are getting so large, and cable bend radius, being able to route cables effectively inside servers are really challenging engineers across our industry. So in order to kind of help alleviate some of those challenges, the DCMHS folks are working to enable 48 volt architecture inside servers. So of course, the main couple benefits with that are, increasing the amount of power that you can deliver in between boards or get back from the bus bar, along with, being able to use smaller wire gauges, improve bend radius and cable routing inside the server itself. And so a couple of areas they were looking to do this for are going from the bus bar to various boards with inside servers, as well as like what we would call a cable to board solution, or something that would go from like a host processor module to a PDB. A couple of key requirements that we'll talk about some more in a minute. Of course, size is very paramount. So we were not allowed to increase size at all. Has to be the same footprint or smaller. And then the last thing I kind of wanted to touch on here is shifting to 48 volts inside servers, makes a lot of sense to me. Going from, if you look at the rack side, with ORV2 to ORV3 and that shift going from 12 volts to 48 volts, this is very much falls in line with that. So aligns with the ORV3 architecture as well. So this next slide I actually stole from the committee. This was actually part of the original problem statement that we received, and I think it's been shared at least once with OCP during a presentation at the global side. And what I really wanted to highlight here is the committee was looking to really enable two new connectors. So number one, this 48 volt peak power, which is shown in yellow or gold on the diagram on the right. And the second one is this 48 volt dedicated supply, which is the black rectangle in the diagram on the right. And so for the 48 volt peak power, as you can see, it's really designed to go more from like a PDB to a host processor module or a motherboard, whereas the dedicated supply is really designed to go more from the bus bar, or what we'll call an IT gear connector, to the host processor module or the motherboard. And of course, the other thing, especially with that 48 volt dedicated supply, is the connector that mates with the bus bar, of course, has to be compliant with it, be able to accept those wire gauges and support those power levels necessary. So this is a little bit of a diagram on what we're trying to enable here. So the committee reached out to experts across industry, with an RFP. It's 5 or 6 pages of very small single space text. I did my best to kind of summarize that for our group today and take all of that information and kind of take what I felt were some of the more important items out of there and just kind of quickly summarize it for folks in a digestible way. So for the 48 volt peak power, we'll call this a cable to board solution, or again, going from more like a PDB to a HPM. There's a couple of different versions for this. There's of course a right angle and a straight version. Size of course is very important. So again, I'm going to keep emphasizing it has to be the same size or smaller than the existing 12 volt solution, which it is. And there's a vertical and a right angle. There is also a high power and a low power. So there are 4 different versions of this 48 volt PIC power connector. A couple things to emphasize are the vertical and the right angle do have the same footprint. For the high power version, there are 12 power pins. So there are 6 return, 6 supply power pins, and then there's also 12 sidebands for signal. The mating sequence was something that the committee dictated to us. We fully agree and support this. So from a first to mate, last to break standpoint, it's going to be return and then supply, and then the sideband or signal is going to be last to mate and first to break, which is best for safety. So this way you can ensure your connector is fully seated and fully mated before you actually transfer any power over those power pins. A couple other key requirements would be, of course, keying and latching. Keying is something that we have a slide on in a couple of minutes to show more detail on that, but we need to make sure that these 2 new connectors, along with the 12 volt PIC power, are not intermatable. So nothing can mate with each other. And obviously latching these days is a very key requirement as well, making sure that the connector stays installed once it is installed. And then the committee gave an excursion support requirement as well for extra high currents. On the dedicated 48 supply side, and this is the one that's again going from what we call an IT gear connector to a cable to a board. Some folks will call it a bar clip or a 48 volt ORV3 IT gear clip. But essentially connectivity from the bus bar to an HPM within a server is what this is doing. There is only one version of this currently. It's a vertical header. Just like the 48 volt high power, it's a 2x6 with 12 pins for power. So 6 for supply, 6 for return. There are some differences with the sense, both in the quantity of the wire gauge and how much current those can carry. But the power level is the same. It's about 3.3 kilowatts for both the high power 48 volt PIC power, as well as for this 48 volt dedicated supply. Also on the dedicated supply, again, we have to make sure that it can mate with our IT gear connector at the specified wire gauges and power levels from the committee, which it can. So, and again, the mating sequence is the same that we just described with the return, then the supply, and then finally the sense being last to make, first to break, which is again best for safety.
Is the connector blind mate capable?
I tend to think no on this one. Michael, if you think otherwise, let me know or feel free to chime in, but I think you'd need to be able to look at this one when you're mating it.
Yeah, I guess the keying is going to keep you from mating it incorrectly, but there's not any overly large guideposts or anything to aid with the blind mate. It should be pretty much the same as whatever the 12 volt is doing from a blind mate perspective, but you can't plug it in incorrectly without looking. You would just have a hard time trying to find center, potentially.
Yeah, thanks, Michael. And along those same lines too, like guide features or something like that is something that can be discussed. The trade-off that you're going to have to make for adding that capability is it's going to have to grow. And one thing that was really emphasized here was size and making sure that this was the same size or smaller as the existing solution. So that would probably be the trade-off for adding that kind of feature in here. Okay.
I have a question. How?
Sure,
Dan, if you are, would you mute? Thank you.
Okay, I have a question. How do we have a short pin for present? So like the present pin only so-called put to ground when the connector are fully inserted.
Sorry, maybe I couldn't quite follow your question there. Could you restate it, or Michael, if you caught it, feel free to answer.
Yeah, I wonder if usually this kind of connector have a present pin, right? So you detect whether the connector is present or not. Is there a way to maybe more genetically, it's like how do we ensure that this connector are plugged in properly if they are not dangling, just touching? One way to do it is by a short present pin, so that if it's just touching the pin, the present pin are not grounded. But if you plug it all the way, then the present pin is grounded. That's one way to detect.
So this connector and the methodology for the sequence follows for the PIC power connector. It follows the same guidance and approach as the 12 volt where it includes a recommendation, the spec includes a recommendation for how to ensure that the connector is fully mated before turning it on and enabling the load.
How is that recommended?
So there's a power enable recommendation where one of the sense signals or one of the sideband signals is used for power enable, and that way the power enable will not enable the load until it's connected.
But how do we know it's just connecting, touching versus a proper mate?
Well, so the sideband won't connect until after the power is fully connected, as Hal was describing.
Oh, so there's like, if you're just touching the sideband, it's like short enough that it doesn't connect. You have to push it all the
Correct.
way.
Correct.
Okay.
Yeah,
got it.
this connector mates return supply, then sideband. So sideband is the shortest pin.
Got it. Thank you.
And then in the dedicated 48-volt supply, it uses the same mating sequence as the ORV3 clip. So it ensures that the load won't be enabled until the sense connection is present. And it's also the last to mate.
Okay, good. Thank you.
Yeah, thanks, Cliff, and thanks, Damien. It's a good question, and I appreciate the detail in your answer, Cliff. Okay, moving on here. So what we're quickly describing is just images of the vertical header and the right angle header and plug for the 48-volt PIC high power version. This is the one that's 2x6. So what you can see here are the 12 pins for power are on the top. Those can be in a couple of different wire gauges, and then your sidebands are on the bottom. So this view here on the bottom very clearly states that with the supply on the top, the return in the middle, and then the sidebands on the bottom. And this was how the committee requested it from us. So this just kind of follows with the committee's request and guidelines. And this would also be the same for the low power, and then the dedicated supply also follows the same structure. So we talked about keying a couple minutes ago. This slide here goes into a little bit more detail. Again, for us, the main thing that we wanted to make sure that we ensured was that none of this stuff was intermatable. If someone accidentally tries to plug something in, it will not go. Just mechanically, it won't fit. So for the 12-volt PIC power, you can see that the plug and the receptacle openings are a different size, as well as a different shape, actually. And then on the 48-volt PIC power and 48-volt dedicated supply, while they are the same size pin openings, you can see there is a unique directional keying, and that chamfer is located in a different space. So those are also not intermatable. Further, to kind of help technicians, operators, and engineers distinguish between these, we also selected different colors for each version. Our understanding for what's out there in the field for the 12-volt PIC power connector is that these are mostly made in black today. So for the 48-volt PIC power, we went with a natural color, and then the 48-volt dedicated supply will be gray. Okay, so each one, we obviously responded back with some more detailed design specifications. This is a little bit more of a summary, and I have it for each version, but I'll probably only go through this one in a little bit of detail, and I'll go very quickly over the next couple. But again, for the 48-volt PIC power, the 2x6 high power version, there is vertical and right angle versions of this. The UL 30-degree T-rise requirement applies here, just as it will for pretty much every interconnect design that we make in this space. This table has more information on the supported wire gauges and target current that it can carry per pin. So of course, this big one is the 14-gauge wire with 12 amps per pin, so enables 72 amps total for the connector. And then you can also see some information on the sideband wire gauge and how much current that can carry. As we just talked about, there's the mating sequence information below with return, then supply, and sideband. And I would emphasize that safety and ensuring that power delivery is not accidentally delivered in a partial mate condition. We ensured that cannot happen here. So that is not an issue that we're expecting from a technical standpoint. Voltage operation and operating temperature included, as well as some durability and latch retention force information. And then last thing we touch on, just to have a little bit of a manufacturing background. So all of these are pin and paste compatible. So for example, if it could help save you some money and time on the wave step if this is the only wave part on your board. So similar on the low power version, without going through this in too much detail, the main differences are this is a 2x3 instead of a 2x6. There's also fewer sidebands. I would also highlight that the 14 gauge wire here can carry a little bit more current than on the high power version, just due to some improved thermal performance. A lot of what you see here below with the voltage ratings and the mating sequences and all of that is the same that I just covered. For the 48 volt dedicated supply, very similar here as well, same mating sequence. What I would highlight is that the sense is a little bit different. It's a little bit larger wire gauge and can carry a little bit more current per pin, but there's also only 2 of them versus 6 or 12, as you would see on the other connector variant. So that's kind of some high level differences there for you on the 48 volt dedicated supply. And of course, this one needs to be able to mate with the bus bar connector, or we call our TEIT gear connector, or what's commonly called the bar clip in industry. Next, I mentioned earlier that we are going to be introducing a design specification for this, so just want to go over a couple of quick highlights. It'll be the 48 volt peak power and dedicated supply revision 1.0. We are expecting to contribute this to OCP in Q3 of this year. From a high level, some of the information that we're going to include, of course, is detailed dimensions as well as pinout information. You can see here on the right, we have a couple of images from a current draft of the spec. So for example, here we show the pin definition, kind of like I highlighted a couple of slides ago, with the supply, return, and then the sideband locations. And then on the right there, you can see we're highlighting that, for example, for the 48 volt peak power, the vertical and the right angle footprints are the same, and kind of showing some more detailed dimensions for what those are. For next steps, like I just said, we're going to contribute this design specification to OCP. That's probably the big one. In addition to that, we are going to add parts to the official DCMHS connectors list. These will show up there soon. And then tool parts will be available in Q3 of this year, so it's pretty much ready to go. And that's the information that I have to share with everybody today. So just want to say thank you and open it up for questions.
Thank you very much. This was a thorough presentation, very much detailed.
Anybody else? All right, thank you, Hal.
Thanks, Al.
Thanks, y'all. Thanks, John.
I did hear back from Brian that there's no other MHS update for this month. They canceled their monthly platform. They just got through with a whole round of tech updates. I think they're lacking for a bit right now. Next up, we have Jack Harwood with the AI software hardware co-design.
Hi. Can you see my slide? Can you hear me?
Yes, I can hear you.
Did the slide come up?
And yes, I can see the slide.
Okay. So a little bit of background noise, but I'll talk over it. So in terms of where we are for this past month, we're still driving kind of the white paper, and we've kind of broken up the modeling simulation work in the AI data center space. We do have to connect with CMIC on his supercluster builder, which he's also submitted for a talk. But we're working on some components, and so we do have a fabric. We actually have an algorithm space we're going through, and around data services. So we're attacking our white paper and our modeling simulation work around 3 different fronts. And it gives us a way to investigate some topologies and some device models as we look at storage for AI. As part of this, the Keysight team had submitted kind of an initial schema to work with the AstroSim simulator for simulating AI networks and AI data centers, AI, at scale for compute communication. So we're going to take that schema, and with John and Rob Coyle, we talked about submitting that in for standardization. So we're building out the slide deck now. We're going to do a review next week, and then we're going to present kind of our proposal to move towards the standard for the Open Systems for AI July 9th. And so if that all seems to go well, then we're going to basically just build out the document, and hopefully by Global Summit, we'll have a proposal for us to standardize the schema around some of the elements. And what does it take for us to do that? So our goal for July 9th with the AI team at OCP is to really not only talk about the work we want to do, but who we should collaborate with, how we should actually do this, and gain some consensus across OCP. As we actually start to look at the way we're approaching this, we are gearing the entire space around compute communication. So whether it's collectives in terms of the tracing, the way we actually do new compute models and how they actually interact, or the way we do data services and storage, it's a common model that we're actually going to build up, and we're going to contribute that back into the AstroSim space, which is driven by Chakra through ML Commons, as well as the schema that we're going to actually propose up. So as part of this, we took all of the work that we're doing and we divided it into, I think we're about 8 submissions that we have. I'm trying to track, because there's a couple of them didn't make it into the global breakout that John and I got for review. And I'm just trying to see if, where they are in terms of the overall space. But we're pulling together and say, okay, what parts can we do that we would allow for our work group, and work with John and team as we get a breakout, because our talk, I think we were grouped with Server, Nick, HPC, and this working group as part of a breakout session at OCP, and we're trying to figure out what talks, what kinds of things. And so we'd like, more than likely, as John said, we're oversubscribed. And so we're going to try to see what we can do to consolidate, combine as needed to get the point across, share some things to talk about systems, talk about fabrics, talk about compute, talk about schema, talk about modeling, and services. And so, as I said, we're on our path for standardization. So we're going to present on 7.9, and I can reflect back to this group, what was the outcome of that. But if anybody's looking to participate, join in, work on any particular piece, just let myself or Wei Feng know, and we're staying pretty well connected with John in terms of the overall space. But our goal is to kind of give a good representation of the work for Global Summit, both in terms of modeling work, but also in terms of the presentations to talk about the work that we're doing for modeling and standardization. Okay, that's it for today.
All right, thank you, Jack. Anybody have any questions or comments for Jack?
Thank you.
All right. Next up, we have the HPC. So Alan, I did mute you earlier since you were having a lot of background noise. I'm trying to unmute you. I've asked to unmute you. It doesn't look like I can do it.
Can you hear me okay?
Yes, we can hear you now.
Yeah. So not much of an update from me, just verbal. We had a vacation, so we missed one of our meetings. But just on Tuesday, just gone, a company called Cluster Vision presented their Trinity X Cluster Manager for HPC and AI, which they are proposing to contribute to OCP. So the recording of that is available on the OCP HPC site if people want to listen to it. I'm very interested. But that's all I've got for today.
Okay. Thank you. Next up, we have the composable memory systems ready.
Yeah. So quick verbal update. So the both the CMS project meetings as well as we have a few work streams. We are all collectively focusing on enabling the pooling based architecture plus the white papers for the fabric attached memory. Currently the focus is really the CXL based, the fabric attached memory. So this includes the use cases, specific focus on AI inference, for example, KV cache offload as an example. So the use cases and workloads are exploring AI specific, AI and big data specific workloads and what we need to do to take advantage of the fabric attached memory. And then we also have a very big focus on data center wide memory orchestration. This includes fabric attached memory, using the DMTF redfish profiles with specific focus on the CXL redfish profiles. So currently the team is actually drafting a white paper that explains how we can actually compose memory resources in the data center from tops down, from Kubernetes all the way down to the host plus the CXL switch, the memory resources. The goal is to have that white paper ready for published before the global summit. So that's the other activity that is actively going on. So in general, the summary is the focus is to look at the fabric attached memory, figure out how best we can actually consume at a data center level, and outline the use cases, workloads, orchestration flows, and translate that into white papers. So that's the key focus area. The second one, obviously, is we have a global summit. We have a composable memory system track. We are actively, reviewing the submissions, and we need to actually close on that part and the demos in the innovation village. That is actually the in parallel focused activity. Any questions?
No.
That's all I have,
Sounds
John.
good. Anybody else? All right. Thanks, Freddie.
Thank you.
Next up, we have Jawad on open chiplet economy.
Hi, John. Can I share?
Yes, you can share.
Okay, so yesterday we presented at the OCP AI ML IT infrastructure silicon workshop, which I think was the first part of it. And most of our work streams, they did give an update. It's pretty interesting. I'll encourage you to look at the recording if you're interested on the silicon side of things. And I'll just flash the agenda here. So it was basically a 3-hour event. And we did cover some of the activity from our work streams related to bunch of wires, as well as virtual prototyping, which is our business work stream that has come up with some of the ideas on how to enable industry to be able to check for interoperability at the protocol level. We did have presentations on some of the workload modeling for HPC and AI. That's our HPC modularity work stream, and what kind of chiplet opportunities are on the optical side, and how do we adapt bunch of wires for optical. We also covered the activity in chiplet systems work stream, where the idea really is to how to compose systems by or I'd say subsystems at the chip level by disaggregating die into different functions. And then we had a wrap up of this with some of the future work that we are planning related to newer technologies on the horizon for abundance of wires, and what kind of additional power and thermal issues that would bring along, though it will deliver a lot more performance at the silicon level. So this was a lot of effort went into preparing for this one. In addition, we have finalized our program for Asia Pacific Taiwan Summit, and we have all the speakers lined up. Also on August 8th, right after APAC, here in Silicon Valley, right after Flash Memory Summit, we'll have a one-day workshop at Carnegie Mellon University at Moffett Field that has a lot of there was a lot of demand that we got to redo this one. We did this event last year, and there will be updates to that this year on August 8th. We are going through all the Global Summit presentations, and we have a full day event on Wednesday that week. We are right now trying to work on the Innovation Village submissions from the OCE. So it's a pretty busy summer schedule for us. So that's about it. I'm happy to answer any questions. And one thing, as always, we like to get more participation, and with some of this AI-focused work, if you want to drop into one of our work streams, would love to get system-level view. And John, all yours. John, you're muted.
Sorry about that. Thank you, Java. One thing to note is that the workshop is already online. So if anybody goes to the main OCP page, events, past events, the Tuesday's workshop is right here. So that agenda that Jawad put up is right here. And the whole 3-hour recording is right here if you want to look at any of the specific slides or view the recording from that workshop on Tuesday. That's one nice thing about OCP. Since it is open, they do a good job of taking the past events here. This past events tab typically has all the slides and recordings from everything we do that's public. I just wanted to highlight that, and it's already up there from Tuesday. Workstream initiatives updates. Like I said, we just did have that one workshop for open systems for AI. There's 2 more coming up in July and August. Greg, I don't think we have anything else to talk about for open systems for AI. Do you?
I do not, no.
Okay. And I don't believe we have any updates for the immersion cooling external PCI connectivity or OCP SIOV2, unless anybody out there has an update for those. All right, that's the end of the agenda for today. I'd like to thank everyone for attending, and we'll see everyone at the summit, if not before. Oh, well, we'll see you next month, but the summit is coming up quickly. It says October, but we're already doing a lot of work on it, so it feels like it's a lot closer than that. So everyone have a good month, and we'll talk to you next month.
Bye.